Hey everyone, Stelvio here. Welcome back to the channel where we break down data architecture and everything in between. If you are into database and tech, make sure to hit that subscribe button here below, like this video, and share with your datamates. Today we are diving into the world of databases, but not just any databases. Look at that. There are so many types, relational, graph, time series, NoSQL, vector, blockchain, and more. But what do they all mean? And more importantly, when should you use one over another? Stick around and we unpack all the different kinds of databases, explore real-world use cases, and help you to choose the right tool for your data-driven solution. Let's go. Here we are now. It's the time of hierarchical databases. So what exactly is an hierarchical database? Well, data is stored in a tree-like structure. Think of it like a family tree or an organizational chart where each record has a single parent or potentially many child records. This one-to-many relationship makes it perfect for organizing data in a structured way. As you can see in the tree diagram, the parent node holds the main data and the child nodes store related data. This hierarchy is especially useful when there is a natural one-to-many relationship between pieces of information. For example, a company might have one parent node for the entire organization with child nodes representing different departments, teams, or employees. Hierarchical databases are commonly used in scenarios like organizational chart, exactly, where each department has a manager and every employee is part of the team. They are also ideal for file systems where files are stored in folders and subfolders in a clear hierarchy. One of the most famous example of a hierarchical database is IBM Information Management System, which has been used for decades in industry like banking and telecommunications to store large structured data in a tree-like format. Another famous application that has historically used an hierarchical database is a airline reservation system. For instance, in these systems, flights are organized in a hierarchical structure. Airlines at the top level, followed by the flights routes and then specific flights instances. Each piece of information is linked in a parent-child relationship, ensuring quick access and clear organization of flight data. So to write it up, hierarchical databases are great for storing data in a tree structure with a one-to-many relationship. They are often used in organizational chart, file system, and legacy systems with example like IBM IMS and airline reservation systems, making the most of the hierarchical design. Alright, moving on to the object-oriented databases. So what exactly is an object-oriented database? Well, as the name suggests, these databases stores data as objects, just like the objects in object-oriented programming. If you are familiar with object-oriented programming languages, you know that an object is a collection of both data, which is attributes, and functions, which are the methods that operate on the data. In an object-oriented database, data is stored as an object that directly map to the application's code. This is different from the normal database relational databases where data is stored in tables and you need to map it back to your objects. With object-oriented databases, the structure in your database mirrors the structure of your code, making the data retrieval much more straightforward. Object-oriented databases are particularly useful for storing complex data structures, like those used in simulation, graphics, and applications that need to work with rich interconnected data. A famous example of an application that uses an object-oriented database is embedded systems. In modern cars, for instance, systems like navigations needs to store complex data structures such as engine states or GPS location. An object-oriented database allows these systems to map real-world objects like vehicle parts or routes directly to the database, simplifying development and improving efficiency. So to summarize, object-oriented databases store data as objects, aligning perfectly with the object-oriented principles, programming principles. They are ideal for application requiring direct mapping between the database and application objects, such as in automotive embedded systems or simulations. And popular examples includes ObjectDB, DB4O, and yeah, others. Good. All right. So let's go ahead to talk about the graph databases. So what exactly is a graph database? Well, as the name suggests, graph databases store data in the form of graphs. But what does that mean? In simple terms, data is represented as nodes, entities, and edge relationships. These graphs make it easy to model and analyze complex relationships between different data points. Imagine you are trying to model a social network. Each person in the network is a node, and the relationship between them, like friendship or followers or connections, are represented as edge. The power of these databases lies in their ability to quickly reverse these relationships, allowing for very fast queries on complex data. Graph databases are perfect for scenarios where relationships between entities are crucial. This includes applications, exactly as we already said, social networks, where you need to analyze connection between users, or maybe also fraud detection, where you need to identify suspicious relationship or behaviors, and personalized recommendations, where you analyze user preferences to suggest products or content. Some popular graphs databases include Neo4j, Amazon Neptune, and MongoDB. These databases are built to efficiently store and query graph data. A famous application that heavily relies on graph databases is LinkedIn. LinkedIn is essentially a massive professional network, and graph databases are perfect for modeling the complex relationships between users, such as connection, job recommendations, group memberships, and more. LinkedIn uses a graph database to help users discover connections, recommend jobs, for instance, and even show people you may know based on existing network, your existing network. So to summarize, graphs databases are designed to store and analyze relationships between entities using nodes and edges. They are ideal for use cases like social network, fraud detection, and personalized recommendations. Examples like Neo4j, Amazon Neptune, and LinkedIn shows how powerful and versatile graph database can be. And that's wrap on today. Dive into databases. I hope you find this breakdown helpful. If you enjoyed this video, don't forget to hit the like button, subscribe, and turn on the notification bell. Also, let me know in the comment section down below what's your favorite database. Thanks for watching, and I'll see you in the next one. Stay curious, keep learning.